So now in this video, we're going to look at the 7410 integrated circuit. So this particular one, it's on the board already, is the 74HC10. I have it there. I fried that one. I bought another kit though, in case I want to use the 7405, the HC05, or any other ones I end up frying in the future. Hopefully no more. But in any case, HC stands for high-speed CMOS. I also have the low-power Schottky kit, but it does not have a 74 LS10, and so I don't know if they even make one in low power Schottky or not. But in any case, this is the only one I have. So this is a triple. You can see there's 3 of them, 3 input. So each one of these has 3 inputs right there, and it's a NAND gate. So there's the schematic symbol for the NAND gate right there, and so there's a little schematic that I drew where each one of those is right there. And the truth table, so there it says NAND right there. It's pretty simple. So an AND gate, so without the end, N is not AND, a regular AND gate, if all of the inputs are high, that's the only time the output is high. As long as one or more are low, the output will be low. This is the opposite. So when all the inputs are high, that's high, that's high, that's high, then the output will not be high. And so NAND. Whereas anytime there's a low input, the output is high. So pretty straightforward. We will build on the most awkward of these. So here you can see we got 3 inputs in a row. That one, 3 inputs in a row. This one, we got 2 inputs on the left, 1 input on the right, and the output. Y for the output. I don't know why is output. That's usually what I see is Y on the data sheet for output. Now, we have to power the integrated circuit. So pin 14, positive rail. Right now I got 5 volts. Pin number 7, the bottom left pin down there, to the negative rail. I have 2 of the inputs that we're not going to use connected directly to the positive rail. That should be the case with all the inputs we are not using. The power supply, as you can see, has about 13 milliamps of current flowing when it's shunt. It may even hover. There you can see it's moving as I put my finger there. It's picking up stray signals to those inputs, and so transistors are turning on and off, and that's not a good thing, but it's not end of the world either. So I'm not going to make a big deal out of it in this video. I'm going to leave them floating other than the 2, but you should either connect them directly to the positive rail or the negative rail. You can read the data sheet for more information. Make sure you read the data sheet. Don't go by everything I say at all. Always go by the data sheet. So in any case, we saw before, we need all the inputs high for the output to be low. Let's get the output out of the way. So we can either put, we're going to use an LED to see whether the output's high or low, and I want the LED to light up when the output's high. So I'm going to put the long lead, the anode, 1 row above this jumper, short lead, the cathode, to that jumper right there, and I'm going to take a 1 kilo ohm resistor. So it's not going to be much current. This LED blocks about 3 volts, and we may only have like 4 volts coming out of the output, so won't be a lot of current, probably maybe even only 1 milliamp. But in case, these green LEDs light up pretty good. As you can see, it's lit up there, and so that is to the output there, and then to the anode of the LED. And if we zoom back, you can see the power supply is only like 16, 17 milliamps. So it's got all those floating inputs, and so we have that extra current. Now, we're going to take 10 kilo ohm resistors, and we saw before we need a high input at all of the inputs to set the output low, and that will end up turning the LED off. So right now it's actually floating. It's kind of turning on and off rapidly because the inputs are floating. So we'll go to the positive rail there, and that, interestingly enough, was enough to get it off. But we'll grab this one, put it to the positive rail there. Now, what we're going to do is, that's holding all the inputs high. So I'm going to take this jumper, and I'm not going to color code these jumpers. I got a red one and a green one. I usually like to use blue for more negative. But there you can see we give a low signal, a direct connection to the negative rail to just one of the pins. The other two are high. That overpowers the resistor. It holds it to the positive rail until we give a direct connection to the negative rail. Then whatever energy gets through the resistor just gets sucked right to the rail. The input doesn't see it. So that is the top one there. We'll go down one more, giving a low right there. It's on, and we'll jump across a low input right there. Again, the LED is on. So we could you know, attach to any of those. Another thing we can do is, first let's move the resistor up one spot. So now the LED will light up when the long lead is going to that jumper right there, and short lead now is to the resistor. So right now the output is low. That's because all of the inputs are high. That's the only time the output is low, and now the output is high. That's why the LED is off. So we can either sync or source. So now it's off. If I move it down one, now it's on because the output is high. That's high up there, that's low there. So high, low, we got current flow. So we don't have to use the resistors to pull up. In fact, I'm thinking it's probably more common that they are pulling down. So I'm going to shuffle them all over until they have a low input right there, negative rail, 0 volts, however you want to label it. So make sure that goes to the input up there. So now they're all low, the output is high. And I'll move this so we can see the pin layout a little easier. So now I'm going to shuffle this over to the positive rail there, and we'll give a high input to every single one of them. So this one, let's go to the positive rail there, and we'll come across here. So it's a little easier to see what we're doing. So that's going to positive there. So both those inputs now have a high input. We need 3 high inputs though for the output to go low. So we'll grab this one. Since there's clutter up there, we'll put it here, and we're going to squeeze it in. I bumped something I didn't want to. Squeeze that in right there, and the LED turned off. So all the inputs are high right now. So that is the NAND gate. This is a 3 NAND gate, a triple NAND gate integrated circuit, and each one of them has 3 inputs. So there's also, of course, 2 input NAND gates, and I'll probably have a 4 or more input NAND gate integrated circuit too. So there'd be 2 or whatever of those. But here is the truth table, and as you can see, actually I think I did show that before, didn't I? So there's the NAND gate schematic symbol right there with 3 inputs. So you gotta make sure you count the inputs, but the rules work the same. They all have to be high, whether it's 2 or 3 or 4, whatever it is, for the output to be low. And so it's inverted. An AND gate, it'd be all high for the output to be high. So that's it for this video. Make sure you click like, subscribe, and the bell. I'll pop up some other videos here. Make sure you check those out, and make sure you check the data sheet for this component. I will see you in the next video.